Okay, today we're doing a welding demonstration. Always wear proper PPE when welding. Welding helmet, welding respirator, safety glasses, welding gloves, a long sleeve fire retardant shirt, or at a minimum cotton long sleeve shirt that's not going to melt to your skin if it catches fire or if a welding ember comes up and lands on your sleeves. Video playback speed has been sped up in the interest of saving time. So let's get started. Here's the plans I drew up with dimensions. It's going to be an electric vehicle charger pedestal. So this is all basically 1/8 inch thick steel that we're working with. I'm just verifying my dimensions. Whenever you're welding or grinding, you also want to have adequate ventilation and a fire extinguisher nearby. This is a scribe tool, works great for scribing metal. Speed square works great for making sure things are square, scribing 45-degree angles, 90-degree angles, etc. Gives you nice straight lines. Just cutting the material to size. Also, when you're using a grinder like this, you want to check where the sparks are going to make sure you don't have hot sparks hitting something that could catch fire. And I like to label my parts, top, bottom, left side, right side, etc. You can see the scribe line. And you always want to secure the material that you're cutting for safety, so it doesn't move while you're trying to cut it. And so this pedestal that we're building today is going to allow for up to 4 electric vehicle chargers to be bolted to it. Upon researching them, we found it was more cost-effective to fabricate a pedestal in-house as opposed to buying one. That green jacket you see is fire rated. And now I'm just deburring the edges, cleaning them up. Just trying to grind off some of the mill scale where I'm going to be welding to. You grind off the mill scale, you want nice clean parent material. That'll give you the best weld quality. These magnetic triangles work great for holding your material in place while you tack it together. And keep in mind, you want to check for square as you tack your material together, because during the welding process, it may move slightly and go out of square. And we will be using a 120 volt wire feed welder for this project with flux core wire 0.035. This little guy right here works great. Inverter type welder. So I got the welder turned on, and obviously I put a metal plate on top of my wooden workbench. We don't want to weld on top of wood for obvious fire safety reasons. I like to use this anti-spatter. Just spray a little bit. It helps with cleanup, especially with flux core welding. And again, I'm just simply tacking my pieces together right now. The key with using that anti-spatter spray, you do not want to spray too much. You just need a very light spray, and that's it. Again, checking my square as I go. And you may have to, that's a chipping hammer, a wire brush to clean as I go. You may have to adjust your wire speed and your heat as you're tacking this together. So common sense, if it looks too hot, turn your heat down a little bit. If the weld looks too cold, turn your heat up a little bit. And there you go, it's tacked together. And it slides on perfect. So again, just a light coating of the anti-spatter, not a lot. Now I'm going to do my weld beads. And you just want to go nice and slow and steady. Don't rush the weld process. Kind of see what it looks like. And we're going to chip off the flux. Now, obviously, if this was MIG or TIG welding, you wouldn't have to chip off the flux. But again, with flux core, you're going to have to chip off or wire wheel off that flux. And there's different welding patterns you can do. You can do little cursive E's, lowercase cursive E's over and over again. Or you can do like the letter C over and over again. That's sort of the motion that you'll use with your welding stinger. And here you see me just grinding a little bit of a groove into this joint on these two plates where they meet the top plate. And that will give me a better penetration with my welds across there, because we do not want to see any welds. So this is all going to be smoothed out and sanded and polished nicely. So I don't just want to weld sitting on the surface. I want it to be in that groove so it's nice and strong. And you don't want the tip of your welder too far away from the surface you're welding on, but you also don't want it too close where you accidentally stick the welding tip to the surface. So again, proper speed, proper distance. Again, that's kind of what it looks like there. We'll do the other side. But again, you want clean material, take your time. You could even practice on a scrap piece of metal first to make sure you got your welding wire speed set correctly and the heat setting set correctly. And again, for this project, we do not want to see any of the welds. So I'm going to have to smooth all those out, polish it out, so you can't see any of the seams is the goal. Whether you're using a cutting wheel, grinding wheel, sanding disc, etc., you still want to wear proper PPE, protect your face, your eyes, wear a respirator. You do not want to breathe in that grinding particulate. So you can start to see now we've smoothed out all of our welds. It's looking like one homogeneous piece with no seams. There you go. And I'll clean up the inside. We don't need to weld on the inside. Okay, now here's a 4" by 4" by 7-foot long square tube that will serve as the actual main structure of the pedestal. So I'm just going through doing some prep work on the surface, deburring the ends, grinding off the mill scale. And then you also want to wipe down all of your raw material with acetone or odorless cleaner, because again, you don't want any oil or grease or dirt when you weld. Like odorless mineral spirits. And when you do wipe things down with acetone or odorless mineral spirits, don't just throw the rag in the trash or in your rag bin all crumpled up. There's a potential fire risk there. What I do is I unfold the rag, I set it outside on like a hand railing or on a cart, and let it completely air out and dry out before we discard them. Or you can buy one of those red, flame-proof rag canisters. Okay, so now we're marking our holes for the base plate. The base plate is 1/4 inch thick. And I'm using my center punch to punch the exact center. And that'll help my drill bit get started and know exactly where I need to drill. And we're going to be using this drill press. Again, wear PPE, clamp your work down for safety. It's a good idea to put a little bit of lubricant on your drill bit. when you're drilling large holes, I recommend starting with a smaller pilot hole and then going to a larger drill bit. That works better. It's also easier on your drill bits instead of trying to drill one large hole all at once. So you see me spraying a little bit of lubricant there. Or if you don't have a drill press, you can clamp this plate in a vise and use a handheld drill to drill your holes. Okay, you can also change the speed by changing the position of the belt, which is what I'm doing here. I'm going with a larger drill bit, so I want the speed to slow down. I don't want it to spin as fast. Generally, the larger the drill bit you use, the slower the speed you want to go with. So you can see it's at a different speed now. And you can see we have a larger drill bit now. So it looks fast because the video is sped up, but the drill bit is spinning at the slowest speed. Again, that keeps the drill bit operating cooler, keeps it from wearing out as fast. Spray a little bit of lubricant as you go. There we go. So this is a retractor box. It's like a spring-loaded cord reel inside of there, and that will clamp to the charger cable, and they bolt up top onto this bracket. So I'm just laying out and marking my holes that I need to drill to mount this box to it. There'll be one mounted on either side. I always like to double check and triple check my measurements. Yeah, so we're gonna weld the 4" by 4" square tube post to the base plate. What you see me doing here is creating some 45-degree gussets. We're gonna cut 4 gussets out of this plate, and that'll add extra rigidity or strength at the connection between that 4" square tube post and the base plate. You could also cut these out with an oxyacetylene torch, a shear, plasma torch, etc. However, in this shop, all I have access to is cutting wheels. So you work with what you got. So gussets are basically just little triangle-shaped pieces of metal. Now we're grinding off the mill scale, off of the base plate where we want to weld. Making sure you have a nice clean surface, you can see there. And what I'm going to do is I'm going to screw L brackets to my wood workbench and then clamp the post to those L brackets. There's our 4 gussets. So I want to evenly center that post on the base plate, attaching the L brackets, and I want to make sure it's level, both front to back and left to right. So level and plumb. You can see it's clamped safely, so it's not going to fall on me while I'm trying to weld, and it'll hold position that I put it in. And again, we'll tack it first and then do our final welds. Again, always checking for level. Now, since I'm welding a 1/8 inch thick square tube to this 1/4 inch thick plate, I'm going to turn the heat up a little bit on my welder because I'm welding to a thicker plate now. Because you do not want a cold weld. A cold weld is going to be weak and potentially fail. But you just want to be careful when you're welding thicker material to thinner material or vice versa. You don't want to accidentally burn a hole through your thinner material or warp the thinner material. So again, just making little taps here and there to get it just right. And I'm not using the workbench as a reference for my level. I'm using the levels themselves. Because obviously the workbench is not perfectly level and square. Spraying a little bit of anti-spatter. Everything looks good. And I like to alternate my tack welds. And the reason I like to alternate my tack welds and even my welds in this kind of circumstance is so you're evenly applying heat. In other words, if I just go from one side all the way around and keep going, that 4x4 post is going to have a tendency to move as I weld, and it might end up getting welded at an angle instead of perfectly level and plumb, if that makes sense. So by jumping back and forth with my welds, as you see me doing here from one side to the other, it kind of more evenly distributes the heat. I find that works good to keep things level and square. And that's pretty much the finished product. Obviously, I got a little bit of cleanup work to do there, but at least you get the idea. And you can see the heat transfer through the bottom of the plate. That's a good telltale sign that I got the heat hot enough. Now I'm centering the top mounting bracket on the post. And I'm marking my holes on the post so I can drill the mounting holes to bolt that top mounting bracket to the post. I like to use that step drill bit to clean up the holes that I drill. And I believe we're just using 1/4-20 nuts and bolts for this. But they have a flange built into the head of the bolt and the nut. And what I'm going to do is I'm going to weld the nuts on the inside of the post. That way when I screw the mounting bracket on, you don't have to worry about reaching or trying to figure out how to reach inside to hold the nut while you tighten the bolts down. So that's what you see me tack welding inside there is the nuts. And then I'll repeat the same process on the opposite side. Installing the bolts just to check my work. Yep, looks good. I do the same thing on this side. That's a good look at the nut. You can see the flanged head on the nut and bolt. And they're gnarled, so as you tighten those down upon final assembly, they're going to grab or bite into the metal and hold really well. But that flange on the nut, that gives you something really good to weld to. Looks good. This is the quad mounting plate that the actual electric vehicle chargers are going to bolt to. For now, they're just going to bolt one charger to each side, but they have room to add 2 additional chargers in the future. And I had these plates cut out on a water jet from a local metal shop. So now I'm going to measure up from the floor to where I want the bottom of that quad plate to stop or be mounted to or welded. And I'm going to make a mark on each side, reference mark. Now I'm simply going to slide the quad plate onto that square tubing, line up my center marks, check it for square, and make sure it's evenly spaced from side to side. And then we'll go ahead and tack weld it to the post. And check for square as I go. Then we'll run our final bead. So again, the nice thing about using that anti-spatter, there's not a lot of spatter or little welding balls to clean off. Now we'll weld the other side. Let's do a little bit more prep work. Kind of see what they look like. I'm I'm using just a regular automotive spray spray primer. So I'll spray everything with this gray primer. And then once the primer dries, I'll spray paint it with whatever color that they want me to use. In this case, we're going to spray paint it with a dark gray. And that's pretty much it for the fabrication process. We'll bolt all the components on, we'll install it out at the location, run conduit to it, and put it in service. I hope this demonstration helps you. Please like, share, subscribe, leave me a comment, and thanks for watching.